Hello friends, here we will discuss in this particular video about voltage shunt negative feedback amplifier. As in previous video we have learned voltage series negative feedback amplifier where your input impedance increases, output impedance decreases, your gain factor decreases by application of feedback. Okay, so let's discuss what is the effect of feedback for voltage shunt negative feedback amplifier cases. Here we have to learn voltage shunt negative feedback amplifier. Before going into the circuit of voltage shunt negative feedback amplifier, we have to discuss how we have to draw the particular circuit based on the name of the negative feedback amplifier. Here the topology is voltage shunt negative feedback amplifier. So tell me what will be the sampling parameter. Yes, your sampling parameter will be voltage, right? So whenever I'm saying that sampling parameter is voltage, it is attached with the feedback circuit with the circuit with shunt circuit, right? So it's a voltage, so I will place with a shunt configuration with your forward and feedback. So circuit connection with forward and feedback at the output side with the sampling cases is with shunt circuit. Now your mixing is already in shunt, right? So we'll connect the shunt circuit at the input side as well. Now with the shunt mixing, you should note that whenever I'm saying the mixing is of the type shunt circuit, then the mixing parameter is not the voltage, mixing parameter will be of the type current. So now I have got the idea that at the output side I have voltage and at the input side I have current. So tell me quickly that which kind of amplifier I have to use for the forward amplifier, right? So voltage is the output parameter and the current is the input parameter, right? Output divided by input is nothing but the output divided by input is nothing but the gain, right? But output voltage divided by input current is nothing but the trans resistance, right? Simply I can say that I will be using the trans resistance amplifier, right? So here we are going to draw the circuit fully on the basis of trans resistance circuit to have the configuration of voltage shunt negative feedback amplifier. Cool. This is your voltage shunt negative feedback amplifier where we have I have drawn the dotted rectangle, and that is nothing but your forward amplifier, that is called as a trans resistance amplifier, right? So trans resistance amplifier, that's why Rm will come into picture instead of gain, right? So gain will be in the form of voltage divided by current. Okay, so that's why R is there in the picture. Now tell me what will be the value of B. B here I'm saying that the voltage is sampled, so whatever value at the input of this feedback is nothing but VO, right? And whatever output I will be getting, that is in the form of IF, right? So I can say that this is nothing but IF divided by VO. Very simple thing. So I can say that the B, that is feedback factor, is IF divided by VO. Now let's quickly start the analysis of this particular circuit called as voltage shunt negative feedback amplifier. Let's see that whether what will be the effect on input impedance, output impedance, and gain factor. Gain factor is nothing but Rm. Okay, so here I can say that open loop gain, that is Rm, and that is equal to VO divided by I. Okay, VO divided by II. So that's why I have not considered this RO, because we all know that trans resistance amplifier mein RO is very less as compared to your RL. Okay, simply I can say RM multiplied by II is nothing but VO, and that's what we are here we have drawn in this particular circuit itself. And this is also called as the gain. So this RM is also called as gain without feedback. Okay, so we have to keep this in mind that whatever RM I'm getting, that is nothing but the open loop gain or gain without feedback. Okay, that's not as usual whatever we have studied AV or AI. AV AI is the gain whenever both the parameters are of the same type. Here both the parameters are of different type. One is voltage and another is current, so that's why the representation is in the form of resistance. Let's start with the gain. Okay, here I will not represent it as the voltage gain. It's nothing but simply gain of the amplifier. So gain with feedback. A very simple analysis that we have to understand, that see to it that whenever shunt configuration is presented, then we have to consider KCL. Whenever shunt circuit is presented at the mixing part, then you have to consider KCL, and whenever series representation is connected at the mixing part, then we have to consider the KVL. Very simple. So as I'm saying that this is nothing but the current IS which is flowing, and that is nothing but the total current gets divided into two parts. One is IF and another is current II which is flowing through the resistance Ri. So I can say that what is the value of IS? Let's start with the analysis. Apply KCL at input node. Okay, let's say do the namakaran A, right? So I will do this namakaran as A. Okay, so we will say apply KCL at input node A. We'll get to know that what is IS? IS is divided into two parts. One is IF plus II. Okay, now I don't want the value IF and II. Very clear. This is because what is gain with feedback? I will write it over here. Gain with feedback is nothing but RMF is equal to VO divided by IS. Okay, so we have got IS is there and we want this VO, but VO is not there, right? We want that VO, we'll get that VO from IF and II equation from that particular circuit itself. I know that what is the value of IF from the feedback, right? So from feedback we'll get to know that what is IF? IF is nothing but beta in B into VO, right? Here we'll write, but what is IF? IF is equal to B into VO, and II is nothing but VO divided by RM. See this forward amplifier, RM multiplied by II, and that is nothing but the VO, because RO is not yet considered. RO is very small, so drop across this RO is very small. So this VO itself is nothing but RM into II, so II will become VO divided by RM. So if we put these values, these two values in equation 1, so we'll take this particular value here, we'll take this particular value here, and this is how we'll be getting the value of IS as B into VO plus VO divided by RM. Clear? So let's try to get that IS. VO I will take it common, and then I will get to know that what will be the value? 1 plus RM into B divided by RM. Simple. Whatever value I want is nothing but the ratio VO to RS. So we will be getting VO to RS, and that is nothing but RMF, that is gain with feedback, is nothing but RM divided by 1 plus RM into beta. It's not beta, it's B. So we'll say whatever value I'm getting, that is nothing but the expected value of gain with feedback, right? That is the first parameter for the analysis. So this is the conclusion, that where you are getting the less amount of gain if we connect the feedback circuit. Okay, let's try to get that, how we'll be getting the value of input impedance. So input impedance with feedback. Input impedance with feedback, I will note that RIF is nothing but, what's the value of input impedance with feedback? Here your current is the source at the input side, it's not a voltage, so RIF is related to your VI divided by IS. See this figure. So very clear idea that this is the shunt configuration. So I can say whatever voltage I'm getting over here, that will be same over here, right? So we can say that whatever value of the input impedance with feedback circuit that I'm getting is nothing but with current IS, and whatever input impedance without feedback I'm getting, that is nothing but with the current II only. Only that much change we have to consider. Rest part VI is same. So I can say VI divided by IS, that we have to find out, and once we get that, I will get the input impedance with feedback. And also we have to consider that input impedance. Before learning this RIF, we have to learn input impedance without feedback. So input impedance without feedback is nothing but Ri is equal to simply Vi divided by Ii. Instead of Is, I will replace this Is by Ii, so that we will be getting the input impedance without feedback. We don't want without feedback, we want with feedback. So what we will do, we will say, we'll apply same thing, apply KCL at input, right? So what we will do, we'll be getting Is is equal to II plus IF. What's the value of IF? IF is nothing but, what's the value of IF? IF is B into VO, right? So IF is nothing but B into VO. But what is VO? I know that VO is nothing but RM into II. So VO is nothing but RM into II. Okay, so here we will be getting that Is and Ii ka relationship just now we have considered, right? Now what we'll have to say, what's the value of Is? Is is nothing but Vi divided by Rif, right? So we will say that Is is equal to Vi divided by Rif, right? And what's the value of Ii? Ii is nothing but Vi divided by Ri. So that we'll get to know that resistance with feedback is in the form of resistance without feedback. So let's try to get that. This particular value I will put in this particular equation, and this value I will put in this equation and this equation. This parameter II and Is I am neglecting, and instead of that I will place Vi divided by Rif and Vi divided by Ii, right? So simple. So Vi divided by Rif is equal to I will take common, and I will write it as Vi divided by Ri, and in bracket I will be getting 1 plus Rm into B. Vi ने Vi को मार दिया, right? Yes, now we have got the value of RIF as RIF is equal to Ri divided by 1 plus B into Rm, and this is nothing but your input resistance. This is nothing but what? This is nothing but your input resistance. Okay, so as far as this second equation, this is nothing but your input resistance, or I can say input impedance with feedback. So conclusion is your input impedance with feedback decreases if we are using voltage shunt negative feedback amplifier. Okay, so let's try to get that. What will be the effect on your output impedance? So to calculate the output impedance with feedback, output impedance with feedback, as I said you earlier in previous video, we have learned that whenever we want to find out the output impedance, we have to connect external source Vx at output. And as I said you earlier, if voltage source is present at the input side, we have to short it. If current source is present at the input, we have to open it, because we are replacing it by because we are replacing all the sources by their respective internal resistance, and as the internal resistance of the current source is infinity, that means open circuit, we have to open the input source. So what we'll have to do, and open input source, right? So this is how we will do. I will draw this circuit in short. We can say this is your B is equal to IF divided by VO. This is nothing but the VO. Here you will be getting one resistance, and that is been connected with the voltage source, right? And I can say that this is your resistance. One is directly connected in series combination, and I can say this one is connected like this. Okay, what I have to do, I have to do this change, plus minus Vx. Okay, and the next is we have to open this up, right? Here we will say open circuit. So this is your open circuit. This is the current. What is this current? This current is nothing but IF. This current is nothing but II. I will get the relation between current IF and II such that IF is equal to minus II. That is one first relation that we will be getting. Here we will say that it's nothing but RM into II. Okay, it's nothing but your voltage source only. Okay, and same as that of earlier circuit, we will do the KVL. What we will do, we will apply KVL. We will not redraw this circuit, so we will say we will apply KVL for loop A. So this dotted line represents loop A, and where Vx is the voltage source, current flowing through this RO is nothing but IO. So RO IO will become your voltage drop across RO, and RM II is nothing but another voltage source. So whatever we will be getting, that we will write as far as KVL is concerned, right? So we will say output loop A gives you the Vx minus IO RO minus RM into II is equal to 0, right? So this is how we will be getting the equation for KVL, and from that, keep this in mind that what we have to calculate. We have to calculate the value of in output impedance with feedback. So here we will say that output impedance with feedback is nothing but ROF is equal to, what is this particular ROF? ROF will become Vx divided by Ix, where current flowing through this is nothing but Ix, and that is nearly equal to this IO, right? So here whatever current I will be getting, that will be IO only. So I can also say that Vx divided by Ix only, right? So let's see to it that IO RO RM into II, right? is equal to 0 plus Vx is equal to 0. This is my equation, right? Now what we'll have to do? We'll have to convert this particular II into IF. This is because we can say that, but as Is is equal to 0 because of open circuit, I can say that IF is equal to minus II, or in another sense II is equal to minus IF, right? And also I know that II will become minus IF, and IF I know that it's nothing but B into VO, so we'll write it as minus B into VO. Clear? So we'll put this equation in here. Clear? So it's a very simple phenomena to get that Vx minus IO into RO, minus of minus will become plus B into Rm into VO is equal to 0. Also we will note that, but Vx is equal to VO itself, right? So here we can say that Vx will take common, and IO R0 को right hand side छोड़ देंगे, we'll be getting 1 plus B into Rm, right, is equal to IO into RO. Clear? A very simple task that we will be getting as Vx divided by IO is nothing but Vx divided by Ix is equal to, that will become RO divided by 1 plus B into. Clear? So this is how we will be getting the formula for your output impedance, right? So as far as the voltage shunt negative feedback is considered, this is output impedance with feedback. Okay, so far we have discussed about the gain with feedback, input resistance with feedback, and output resistance with feedback. So we'll have to make a conclusion. Conclusion we will do in the form of tabular. The first is parameter, then we will say without feedback, and this will be with feedback. Okay, first parameter that we have got is gain. Gain is nothing but Rm. Okay, here with feedback we have got the decrement in the gain 1 plus Rm into B. Clear? Second thing that we have got as R input impedance, will not say R, it's input impedance. Here it is Ri, and here we will be getting the again decrement in the input impedance Ri Rm into B, where Rm is nothing but the gain of this particular type of negative feedback. Third is output impedance, and here we will be getting Ro, here Ro divided by 1 plus Rm into B. Clear? So as far as all these three parameters are considered, here we'll be getting decrement, here we'll be getting decrement, and here also we'll be getting the decrement in the parameters output resistance, input resistance, and the gain parameter of voltage shunt negative feedback amplifier. So far we have discussed, and we came to the conclusion that if we want to have the input resistance at the low value, output resistance at the low value, also we want to reduce your gain as well, we can use voltage shunt negative feedback configuration. Thank you so much for watching this particular video. Learn more and more EDC along with me, along with Ekeeda videos. Thank you so much.